I have been working with TDEC for about 32 years, and almost all that time I've been working in a non-regulatory capacity as mostly an assistant to industry. And in the course of that time, I began to really enjoy the reuse of material. I hate waste. I was raised by people that grew up during the Depression, my grandparents, and I just hated things that to go to waste that could have a useful life further on. And although we're going to be discussing materials reuse in Tennessee, I won't be discussing the plastics aspect. I'm going to be talking about, in general, some of the successes and challenges that come with material reuse with industry, particularly with industry. Um, so next slide. Second here. Oh, the same slides on there. There we go. Got it. Okay. So the industrial ecology of material reuse is pretty obvious, and it's the same type of economy that is for regular first run material. There are a few places on the earth that actually do this on purpose. However, in the U.S., as far as I know, is not one of them, and that there are market pressures and various issues that might dissuade companies directly locating next to each other that can use each other's material discards. I can see why that might not be the top. Well, let me just jokingly say, material reuse is. It seems to me it's desired, it's wanted, but it looks like it's number six in everyone's top five list of things they want to accomplish. You got to make a profit. You got to make your products. You've got to make your suppliers, your company, your executive suite, and your customers happy. So, with all of that being said, you don't necessarily focus on the reuse of byproducts or even material waste. So there are two places on the earth I think that do this on purpose. There is, and I'll say it wrong. I apologize. If you're from there, forgive my mispronunciation, but there's a place called Kolenborg. Kolenborg, I believe it's in Denmark. They, on purpose, made an industrial park that located companies next to one another that use each other's material waste. They did it on purpose. And a lot of that stuff actually is, when you really look at it, it's actually steam, which is great. They generate steam from the process of one company. The other company can use it. That's a good thing. And then some wood chips waste and some other things. It's difficult when you don't try to do this on the front end. On the front end, it's not the most profitable aspect, but we need to march forward and start to do this because there are issues with our landfills and various things. And plus, also, it's just really a shame to waste material that doesn't need to be in the landfill because that's kind of a once and done. It can continue to have a life in the economy and generate that useful life as a resource for all of us. So now this is the slide. This is the this is the hurdles of materials networking, which on your left hand side, on your left, there's three checked items right there. There are an issue with almost any transaction of any kind, but in particular with this type of thing. Uh, and then the slide there. This is the first page of a study on online materials waste exchanges, and we all want to live online. That's the most that's the most critical, quick aspect of us getting to know each other, getting in contact with one another. Uh, I have a friend that says eBay should have gone broke. It should have been I mail you junk and you send me a check that bounces. They didn't happen. Um, that's a very successful platform. You can think of, and forgive the crudeness of the analogy, but a dating app, a dating site. There are folks on there that you have certain criteria. You want to know someone better or get to know somebody a bit better. See them offline, work with them offline. You enter into that various criteria that you want, and most of those are pretty successful. Well, why aren't these successful? This study from the Smills Business College, and I believe it was also University of Pennsylvania State University. They did a big study about this with online waste exchanges, and this was 10 years ago. Yeah, and I looked it up against the metrics are the same. Everyone joins. Everyone joins. Everyone wants to get on there and say, "Hey, I'm part of this materials waste exchange network online. My material, my company. We're gonna do this great sustainability thing." And 2 years in, 2% of participants make one trade. So 2% of the participants over across 2 years make one material trade. That's really not the best bang for our buck. So the issues are, as it says on the left hand side there, lack of relationships or a loose industrial coupling, as it's known on the trade world, I suppose. A lack of interest, supplier commitment, and then a lack of trust, which is buyer uncertainty. I think that last one is probably the one that is the most restricting with these sorts of exchanges is buyer uncertainty. It's material waste. I don't know. There's probably not a real assurance that it's going to be of a material quality that I'm going to be able to count on forever. It's going to run out eventually. You're going to get more efficient in your company, have less waste. Various issues that may come up that make these kind of things not have the energy and the passion that it should have. Well, these slides change really slowly. Wow. Here we go. So we have, and this is in its infancy, like 3 or 4 years in. And it's primarily only me right now, but we have a program that's called the Tennessee Material Solutions Program, and we do our best, as you can see these examples here on the slide, to work in all types of materials exchanges, and that means that you have to be an expert, not really an expert, you have to know who is an expert in a lot of different things. It's very, very, very difficult. So we're all looking for, well, my office, us, and a few other people in the industry are looking for something we can do together that tackles one material waste problem that almost everyone is having, and that we can get together and combine our resources together and solve that one issue to get to be more closed loop and a continual successful waste stream reuse. So some examples here, and they're pretty simple. A few examples quickly. Dynamic life cycle solutions took cathode ray tube glass. Cathode ray tube glass that has lead in it uh, from computer monitors and processed it to where there wasn't any lead. And I still don't know how they did that because they won't tell me. But anyway, we did a lot of grab samples and it was free of lead. Florum USA, tile manufacturer in Clarksville, the biggest tile manufacturer, I think, on the planet, I believe, right now, took this material in place of regular sand as a visionary attempt to see if they could do this at scale. And it went very, very well. It was 6 million pounds delivered over 3 years. But the problem, as is obvious, the material is not a constant stream of material. It was going to run down and go away eventually. When's the last time anybody saw even a working CRT, cathode ray tube, old television, or a computer monitor? Those things have been processed. They've either been landfilled, lost to the overall economy stream, or they've been reused in some way. So this is a great heroic attempt. It worked very, very well. Ended up in tiles, but it's not a once and done. But it's limited. Come on, slide change. Here we go. All right, Clayton Homes. Oh, by the way, I'm sorry. Uh, Florum USA and Clayton Homes are members of partners in our Green Star partnership. That's how we work with them to this degree. If you would like to know more about that, you can ask us in the chat. There's a lot more to this than just this program, but the Green Star Partnership is a great leadership program in Tennessee for manufacturers. Lots of good folks in that. So anyway, on to the slide. So Clayton Homes, they make pre-manufactured homes in which they know all the It's not cookie cutter. That tends to make you want to think of a it's a cheap home. They're not cheap. They're great houses. They're prefab. They're manufactured homes, but they know the dimensions. They know where all the outlets and the windows are going to go. So they go ahead and just press out all the gypsum drywall that comes through. So they have a certain amount of waste that they know they're going to have. And most of it is indeed gypsum. There's some that's a prefab base layer, but that was going to the landfill for a good long while. And we tried to use it in some composting operations to assist with the recipe that goes into a good composting mixture. That was pretty small scale. And then we found a agriculture or industry to agriculture aggregator in Arrowhead Ag Recycling. They took the gypsum and with very little mechanical manipulation was able to grind it up into what could be then used in a regular material spreader on a farm to a large scale corn supplement application in only a couple of counties. I don't know if many of you all are farmers, but 3,000 to 5,000 tons of material diverted to Tennessee farms even once a month is it just really isn't all that much. uh, uh, Farmers that work the land work in really large scale numbers, and this is not. It's a great thing to do, but as far as an impact of overall corn crop, even in Tennessee, it's not going to be that that impactful. It's worth doing, but not that impactful. All right, so this one, oh boy, guys, this was Volkswagen Chattanooga. They were adding on an entire new line. This is a major OEM, major vehicle manufacturer that was putting on an entire new line for a brand new vehicle. And the pallets that came in, it was pretty unimaginable. This was a massive pile of pallets, huge. And we again got a processor for recycling that was Rockwood Recycling that actually cited a chipper on site. And now, I don't know if any of you all have ever really handled many pallets, but this was a chipper that could chew these things up into wood chips, separate the nails and things over here. So you had a metal stream and then a wood chipping stream. But that's an immense amount of energy. That's a lot of carbide blades chewing through all that wood, uh, a massive amount of energy being used to then reduce this material down to not going to the landfill, but going to at least one one good time use, one good once and done as a boiler fuel in a pulp paper mill in Georgia. Georgia's got a lot of pulp paper mills, quite a few more than Tennessee does, and they're close to Chattanooga. That was a good outlet for that. But if you ever look at a pallet or thought about the innovation over the years and the energy and the human capital and the material that goes into making just a pallet, it's a simple pallet. It's really awful to take those things, many of which can be reused or refurbished, and turn them into wood chips. There's other sources of wood chip material to be boiler fuel, but they didn't landfill them. Volkswagen is a visionary company. They wanted to be sustainable. They did do this. It was a good project, but again, it's over. It's done. You can only have so many pallets that you chew up at any scale to feed a major boiler at a pulp and paper mill in Georgia. So the next slide. Now this one doesn't have a lot of detail on here. This one, this is proprietary. I can't discuss the details of this very much, except to say this electrolyte material that was contaminated with a wee bit of, I think it was ethanol and some other kind of fuel. I think it was a small amount, but it made it unusable as electrolyte material. It was intended for a very popular, very well-made uh, electric vehicle as the electrolyte for the battery that then makes this car go very fast. It's one of the best ones out there. This material was a specialty material, and it was going to be shipped out as I'm sure some of y'all already you're hearing the cash register go ding 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 all this money. Then be shipped out as a hazardous waste. But we were able to get that stuff to a person that in my opinion, special that I call it he specializes in the misfit toys of the chemical industry. So he took that and was able to do some blending and able to use it in absorbents and fuel additives. Again, that's better than throwing it away. Better than throwing it away. This one, there's not a lot of information on there because I didn't put that on there because this is the one that really exemplifies a lot of the exchanges that I try to get involved with because a lot of times they're just failures, and it's not like it's a bad thing. The failure rate is significant because you're going and trying to take material that wasn't intended for one use, it's waste, it's material that's not being used, and then trying to squeeze that back into the economy somewhere. There's some energy involved, and some effort, some shoe leather, some calls and interactions and some deals and things you have to do. This was this was solved. This was a problem that was totally solved. The aerosol was excuse me, Recycle Aerosol LLC, a great company by the way, were receiving these products they were reusing in these short fiber drums. They had no use for the drums. They didn't want to throw them away, so they kept them on site until we found someone that could use them. The Tennessee Bureau of Investigation, they received these drums for a while to collect pharmaceuticals at counties for our unwanted pharmaceutical program. And of course, those are taken away and taken off and done away with in an incinerator. Um, the location of which we can't divulge. We don't want to tell people where all the unused drugs are going. But these short fiber drums, they're a vector problem. They're eating up available square footage. But certain things happen, and you wouldn't believe that. Well, maybe you would believe this audience would. The smallest things that knock a hole in the whole project. Uh, some of the barrels maybe got wet. Some of them sometimes they may not be picked up on time. Sometimes there's a fallout over just a couple of pennies per barrel. Who knows what the problems might be? I'm not sure what they are. I do know that this current project has been stopped, and it was one of those where you go, "Hey man, this is easy. You need the drums? Here they are. Come get them." Just didn't work out that way. So anyway, we want to solve these issues, and we want these issues to go to something that we can. And there are many examples, many things we can do. But one of the things we could do is get something that major manufacturers have that they then have no way to get rid of that, but take it to a processor, a landfill, get that material back, reconstituted, repurpose it in some way, and get it back to that same manufacturer again. And that's what Matt Korey with Oak Ridge National Labs is going to discuss right now. He's part of the Sustainable Materials. Did I get that right, Matt? Sustainable Materials program. He is with their R&D facility, their R&D office, and I'm masquering his bio. I apologize. Anyway, he's a very smart guy. Works with Oak Ridge National Labs. Going to help us solve a problem. So here we go. I'm going to stop sharing and you myself and hand it over to Matt.
Got it. Thank you very much, Vaughn. Can you hear me? Do you have audio for me?
Yep, we can hear you.
Okay, wonderful. Thank you. Yeah, thank you so much, Vaughn, for the kind introduction. My name is Matthew Korey. I'm a staff scientist at Oak Ridge National Laboratory. As Vaughn indicated, I'm part of the Sustainable Manufacturing Technologies group at Oak Ridge. I'm headquartered in the Manufacturing Sciences Division, and I work primarily in the Manufacturing Demonstration Facility, which is actually about halfway between main campus Oak Ridge National Lab and downtown Knoxville. So it's really nice to be here. Thank you very much again, Vaughn, for the invite to come and speak to everybody today. And I'm going to do my absolute best to stay on time, but if somebody could, cut me off with about 10 minutes left so we have time for questions for everybody, I'd really appreciate it. So for those who aren't aware, Oak Ridge National Lab is one of 17 national labs in the United States. We primarily serve to assist industry and make the U.S. more competitive. So we do not compete on the market. I'm not selling products to the supply chain or anything along those lines, but I serve to essentially help de-risk higher risk technologies that could make our manufacturing industries more efficient or help save costs for people. So I'm today here talking about deriving value from recycled waste. Um, but again, I represent a national lab of about 6,000 people, and I am just one of many, many people working not only in this space but kind of across the energy sector. So um, I just wanted to highlight for everybody who may not be familiar. So I work at the manufacturing demonstration facility. Again, we are a user facility for the Department of Energy. And essentially what that means is it's a lot easier for industry and people who are out in the US supply chain in whatever capacity to kind of come in and leverage the national lab resources to solve the most pressing R&D problems. Oftentimes people, for example, will have a new material that they want to explore for manufacturing to help find an application space. So they will come to MDF and have us work with them to do so. There's a that's just one such example of the kind of research that's being done here. But our focus primarily is early stage R&D, likely and almost always to improve productivity and competitiveness for U.S. manufacturers. And really, our goal for our facility is to de-risk challenges for transformative change. So people don't typically come to us with like iterative projects, they really tend to be very disruptive technologies that we're kind of pushing out to market to help make the US more competitive. I also wanted to highlight that because we are a user facility, we do a lot of industry collaboration. And in fact, the MDF is extremely industry forward. I can't think of a single project I'm working on that does not have an industry angle, industry ownership, things along those lines. And the numbers for this facility speak for themselves. The impacts for the MDF in particular have been exceedingly transformative. Many industries have come and started within this facility. There's a lot of companies that will come in, co-locate their staff in our facility, use our resources, our expertise, and connect with experts in this space, and then use that opportunity to kind of catalyze their company growth, especially for startup companies. And there's just a tremendous number of licensed technologies and patents coming out of this facility, and I'm really honored and blessed to be working here. I also just wanted to highlight some of the impacts of this facility. There's more than 100 publications per year and hundreds of awards since the facility has been opened. I also wanted to highlight that we're about 110,000 square foot facility. We operate more at a pilot, like a small to pilot scale, but certainly larger than what you would see at a university. And so for that reason, we do a lot of work with universities kind of scaling up their exploratory technologies for the industry. And again, helping enable that disruptive, transformative impact. And then, there's at least 220 staff that work at the MDF on any given day. Almost all of them ORNL or, Department of Energy employees. However, we do have a co-located industry that works in our facility in addition to that. And my core expertise within our entire facility is primarily looking at how to derive maximum value from what we would consider traditionally waste products from our manufacturing techniques. So our core competencies are primarily in repurposing of end-of-life materials. So on the left here, you're seeing us using a water jet cutter to repurpose wind turbine blade, which contains a multi-material assembly, actually isolation of a unimaterial stream for further exploration for manufacturing. In this particular case, we were looking at these materials as repurposable for transmission tower infrastructure. In the bottom left there, that's actually a lift gate, a trunk for a Volkswagen vehicle. And the metal clips and components are contamination for the downstream recycling processes. So we here you're just seeing us remove using a water jet cutter those components. In the middle here, we do a lot of work in composites and plastics recycling. So composites being plastics that contain a filler of some kind, often used in the automotive application, aerospace applications, very lightweight materials that perform comparably to what we would consider as state-of-the-art metal materials. And we do a lot of work in recycling these materials and finding applications for them. And then on the right, what you're seeing is the product coming out of a twin screw extruder, a repelletized plastic and composite that can integrate into, it's essentially a platform material that can integrate into a whole host of different manufacturing techniques, be it additive manufacturing, of which we have large format additive manufacturing capabilities in the state of Tennessee, injection molding for products in automotive applications or consumer products, and then of course compression molding and many other manufacturing techniques. So this is to say we really understand how to kind of go from an end of life product or a waste basically to a new value added product, and that's really the goal in the supply chain here. As I'm sure many of you are aware on the call, the profit margins in the recycling industry are very slim, in some cases even less than a penny per pound. And so in order to justify the investment in the infrastructure for recycling, which can be, the capital itself could be very expensive, you need to really de-risk and prove out that these things are possible. No recycler has the bandwidth to stop their run and do exploratory work for a new recycling process. And so we fill that gap. We really try to do this to prove this out so that we can minimize our waste and help save people costs by deferring materials from landfill, for example. And I just wanted to highlight to you all today that I am one of many people working in this space. We have existing projects and efforts in several key areas to this industry. I did want to highlight my group leader, Soydan Ozcan, who's the group leader for Sustainable Manufacturing Technologies at the MDF. He's in the top left there. But there's many people working in this space. We're doing a lot of work because most of the time we don't have the remanufacturing systems, we don't have the technologies yet to really show how we can do this. And so we've developed and built our own equipment as part of this initiative so that we can prove that these things are possible. We do a lot of work in like next generation recycling technologies, including advanced solvolysis technologies, similar to what incredible work is happening at the Eastman plant in Kingsport. But we also have an existing research looking at biological and enzymatic methodologies for more targeted chemical degradation of plastics at end of life. And it allows you more selectivity than you would get from a solvent type process. So rather than having to do separation before recycling, you can actually recycle bulk. And so we have a lot of work in that space. We're also looking at more recyclable materials. Materials like polypropylene, polyolefins can be really challenging to degrade using advanced recycling techniques other than like pyrolysis. And so we're looking at new material systems that are inherently recyclable and easier to recycle. We do a lot of work in multi-material separation. We have a pilot scale, a proof of concept scale density sortation equipment here. We do a lot of work in modifying the sortation media with additives that can drive better density sortation from a multi-material system. And of course, we do a lot of work in cost and environmental impact analysis as part of our initiatives. And so we do, essentially, because we do all of this in-house, we're able to get primary data in terms of what these costs actually cost. We know what our equipment costs, we know what it costs to run the equipment, and we know the energy costs associated with doing it, so we can really get much closer, much better of an understanding of what these processes are actually going to cost. I also just wanted to highlight the scale that we're at. So this is me in this middle photo here. So I'm 6'4". We have a 4,000 pound per hour throughput stacked Cumberland granulator and shredder system. And you're kind of seeing me standing in front of that. So this system allows us to take large composite materials or non-composite materials for, it doesn't really much matter the input material, but we process things as large as wind turbine blades through this process. And our current process has a sieve for a 1/4 inch particle on the back end, but that sieve is interchangeable. So we can change that sieve out to the particle size that's required by the industry. And then understand how that affects our throughput, which then affects, the actual profit that these companies are receiving. And then the other thing for people to be aware of is with plastics, and particularly composites, when you're cutting them with a saw, if you aren't aware, there's a lot of challenges with cutting plastics with saws because they tend to melt the plastic and jam up the saw. And so we do a lot of pre-processing on our watershed cutter on the left to help avoid that problem. And it's been tremendously impactful for us in cutting things as large as wind turbine blades. And then on the right here is our light switch twin screw extruder. This is the ZSC 27 Max system. And this product allows us to manufacture pellets from shredded thermoplastic composites. We also do a lot of work in new material development for extrusion companies. So we do a lot of work with LyondellBasell as well as Techmer, both of which have facilities for compounding in the state of Tennessee. And we do a lot of work with them to kind of prove out and scale up the processing parameters for new materials. So we do a lot of work in that space, especially with recycled materials. That could be a challenge because they process in a non-uniform way because the recycled material itself has variable quality throughout. So we do a lot of work in that space. And I just wanted to highlight only one example, but we have many, many, many examples of this, but I thought this was a cool story and was automotive focused, so it was relevant for people here. And this is entirely within the state of Tennessee. At least the work was done within the state of Tennessee. But this company, AirTech, approached the Oak Ridge team. And on the bottom left here, we have a photo of a production tool. So AirTech they're traditionally very well known for making multi-layer films for vacuum bagging and other applications. So AirTech has a new, well, it's not new anymore, it's several years old, arm of their company where they do large format additive manufacturing. And so this is very large 3D printing essentially. And in order to scale up 3D printing, you can't scale up 3D printing and use a neat polymer because neat polymers, they actually they shrink after you print them. And when you scale up a print large enough, that shrinkage warps the print and can actually cause collision with the printing head. So you have to add like carbon fiber or other fibers into that composite. When you do so, you drive up the cost of the composite. And so this tool here on the bottom left was manufactured with a carbon fiber polycarbonate material, which can run as much as $12 to $25 per pound, depending on who you buy it from. And that tool itself was tens of thousands of dollars to print. So AirTech was contracted to do work from Brumos Racing, where they printed a tool for the front splitter for this race car here. So this car races on Pikes Peak, which is a very steep uphill, very famous race in the US. And that front splitter actually holds the car down on the road so it can go faster as it's going uphill. And they printed this tool. It worked very well, but they did not set a world record with the front splitter. And so they knew they could optimize further to get even better results in the next year's race. So AirTech came to us and they said, this tool is very expensive. Is there any way that we can recycle it and then use it to print this new design that we have? And can we, help save money by doing so? So we did recycle that carbon fiber polycarbonate using our capabilities at MDF. And in the bottom here, you can see this is the new design just as printed using this last year's materials. So this is 100% recycled carbon fiber polycarbonate. In our process, we can produce this using primary data for the pelletized material for about $1 to $1.50 per pound, which for a material like polypropylene is not cost effective, but for a material like carbon fiber polycarbonate is actually very cost competitive. And so we actually did print this tool. It worked, and they were able to set a class record for the class they competed in with this car. And I just wanted to highlight this is my group leader, Soydan Ozcan, and at a conference with the technical lead from AirTech. They were very, very happy with this demonstration. And we do a lot of work like this for people all throughout the U.S. supply chain, many of whom are co-located in Tennessee. And I have more examples I'm happy to talk about, but I wanted to be respectful of everybody's time today. So today I really wanted to hone in specifically on the automotive case study. I know that Tennessee is seen as kind of like a southeastern engine for automotive manufacturing. We have several automotive OEMs that are located in this state. And it's my understanding that more than 140,000 people in the state of Tennessee work for the automotive manufacturing sector. There are many, of course, with any automotive manufacturing facility. There's a lot of tier suppliers, and so there's just a lot of people working in this space, and this is a very important industry for the state of Tennessee. And so I just wanted to highlight here kind of the value proposition for looking at the automotive industry, especially for like plastics and composites recycling at end of life. And the reason why is because in the past several decades, the amount of plastics in cars has been increasing. And they've also been found in more and more diverse applications throughout the vehicle as the years have gone on. And the primary reason for this is because, well, the primary reasons, at least why we're seeing this, are because plastics enable safer vehicle designs, being that plastics can absorb more energy and an impact than a metal can. And also, plastics are very more manufacturable, which means that they're able to be made into much more complex components that are easier to assemble at the plant. But we have a few additional challenges as plastics displace metals in vehicles. They've undoubtedly made the vehicles more energy. They've made them more efficient in that you get more mileage because the cars are lighter, but you make additional challenges at the end of life of the car and more opportunities for R&D to overcome those. So the first major challenge is that there are many, many different materials, on average, hundreds of different grades of plastic in a single vehicle. That makes it really challenging to recover any unimaterial stream in a high enough volume to make it make sense to do the recycling. And then another big challenge with the use of plastics in vehicles is that they're part of very complex multi-material assemblies from which isolation of any one material alone can be cost prohibitive. And so although it is possible to isolate a single connector from within a door panel, one might think that might not be cost effective, right? So one thing that we need to think about. But it's important to note that although this is a challenge, almost all automotive OEMs have sustainability commitments that they have made, pledges that they've made to increase not only recycled content, reduce CO2 emissions, and increase bio-ag content in vehicle designs. However, the European Union has just recently passed legislation that will require vehicle OEMs to incorporate 15% recycled plastics by 2032. So 50% of every plastic in a car needs to be recycled. It needs to be recycled content, excuse me. And then in addition to that, 25% of that 15% needs to be recycled from end-of-life vehicles specifically. So right now, we are not recycling plastics from end-of-life vehicles in any meaningful concentration in the US, but if we as US automotive OEMs want to compete in the European Union, then we have to look to ways to do this. And I would argue it's an opportunity for the US to build a competitive advantage on the global market should we be able to get there first. So just wanted to highlight that. So what plastics recycling technologies exist? Well, there are several, but there are a couple that are pretty key to the automotive industry. And I do want to highlight here quickly that this slide was prepared by my colleague, very close collaborator, Dr. Ellen Lee at Ford. And I have the privilege of sharing with all of you because I think it is such a fantastic summary of what exists. But so props to Ellen. I'm really thrilled to be able to present this to you. There are several key recycling technologies, one of which is mechanical recycling, essentially where you recover a plastic at end of life, you shred it down, and you directly remanufacture the shredded plastic. That is really very low energy process, and that is typically considered one of the cheapest processes. But this process is challenging because it requires a unimaterial stream. So you can't really mechanically recycle all plastics as one mix. You have to get them into a form factor where they can be processed in the same material, the same temperatures, etc. Another process is what's called solvent or chemical recycling. And this process, you basically break down the plastic into small pieces and then you put it into a solvent bath, which degrades the plastic down to its monomer constituents. And then you recover those monomers and you re-react them back into new plastics. This particular process is currently cost prohibitive for many different industries, although Eastman has found process for doing this with PET in the state of Tennessee. And then finally, there are more advanced chemical recycling technologies where you put plastic into a reactor and then you heat up that reactor in a controlled environment and you degrade the plastic down into its basic fundamental building blocks. Then you take those building blocks and you remanufacture them into the monomers. And then you take those monomers and remanufacture them into plastics. As you can see, the farther left we go on this slide, the more complex, the more steps we add to the recycling process. And so for automotive industry, the plastics are very, very low cost. And so it's harder and harder to move farther to the left on this curve for the automotive industry because the price of the plastic that is recycled goes up. And so we really are pushing to mechanical recycling technologies for this industry. I know I have about 10 minutes left, so I'm going to try to move somewhat quickly through the rest of these slides. But we know what the end-of-life supply chain for a vehicle looks like. Typically, end-of-life vehicles they go to the body shop, and if they're totaled, they're sold at auction, typically to a scrapyard or a shredder. But there are also hobbyists that compete in this supply chain. And from the scrapyard, parts will be picked off, especially a lot of plastic parts can be picked off and directly reused. So if you're familiar with LKQ or pull apart, these facilities are typically what we consider a scrapyard. But then there's also an industry, the automotive shredding industry, which will take cars and shred them down to recycle the metals from within them. And the shredding facilities it's very, very challenging to get the plastics out, and I'll kind of talk about why. But the long and the short of it is there's a very robust supply chain for these materials at end of life. I just want to highlight for everybody, though, on this slide, what I'm showing is just the locations of the Napa Auto Care, which is an automotive, a body shop. And in the state of Tennessee alone, we have a whole bunch of these all throughout the state. And for recycling in particular, because the margins are so low, having facilities close by from which we can get materials back can perhaps enable lower costs. I did just want to highlight, we've done a lot of work with automotive shredders, and this video on this slide here is a video of an automotive shredding facility in the state of Michigan. And what you're seeing is a very complex multi-step, multi-material separation process here. They're recovering ferrous, non-ferrous metals in different streams, but the result of this process is actually 3 streams, and I will stop the video when we see those 3 streams. So there's a stream here, and then a stream in the back. You can see them kind of moving during the video. So these 3 streams, one of them is ferrous metals, one of them is non-ferrous metals, that's these 2 here. The stream in the back is what is called automotive shredder residue, and this stream in its entirety is destined for landfill. So this stream contains many, many different materials. We did a robust 10-sample characterization study of what materials are found in this stream. There's plastics, rubber, foam, etc., a bunch of different materials. And even within the plastic stream, there's very mixed content within it. It's going to be very, very challenging to recover any plastic from within this stream in a high enough volume to make it make sense economically. The technologies required to do so are quite complicated and expensive. So there's a lot of R&D that's needed in this space to recover value here. I also wanted to highlight that we've done a lot of work in recovering plastic parts from the scrapyard. Here, these plastics are not shredded. They are simply just dismantled from the car. And for that reason, we're able to get a much more uniform material stream. I did want to highlight, we've looked at several of the key industry plastics, including polypropylene, alkyl polypropylene, and polyamide. These represent low value, high volume, and high value, low volume plastics in vehicles. What we saw is that perform comparably to virgin materials. And what we found is most of the discrepancy between today's virgin materials and today's recycled material is the formulations just got better. So the old materials didn't really degrade, they just are not as good as today's materials because we've engineered them for the last 10 to 15 years. So that was very interesting. So I will stop there for today, but I just wanted to highlight that we think that it's possible to recover these materials from end-of-life vehicles, but there are still questions that remain about whether we can make this economical. We don't yet really understand if we were to do this in the state of Tennessee, where would the facility need to be located to ensure economic viability, excuse me. We also have questions about how we can ensure there's no contamination in the samples. But I just want to highlight that this is an area I think for the state of Tennessee we could be exploring for further R&D. And I did just want to highlight my contact information on the bottom of the slide here. I'll leave this up for anybody who would like to kind of connect with me. This will link you to my ORNL page, and from there you can find my LinkedIn and other ways to get a hold of me. But please feel free if you'd like to try to find value propositions for the waste streams from within your companies. I'd love to connect with you and see what of our capabilities can be leveraged to help do that. So with that, Vaughn, I will stop and we can take any questions if there's any from the audience.
Yeah, thanks, Matt. Let's see. I've got one. Well, there's a couple that have came in actually. Let me pull these. Well, one said, do you guys do site tours at the ORNL MSP? We are nearby and may be interested in seeing things in person.
We do. We have hundreds of tours every year that come through. Please feel free to reach out to me. I'd be more than happy to arrange that for you. And yeah, there's an unbelievable capabilities in this facility.
Yeah, and we, I think, actually are in the works of building out an in-person a pollution prevention workshop with you guys. So yeah, be on the lookout for that. We don't have the exact information right now, but later on in the year, towards the end of the year, late summer, I think we're going to be working through doing an in-person pollution prevention workshop there, where a tour will be a part of that as well. So yeah, just be on the lookout, and I'll mention that in our follow-up email for this webinar as well. I've got, let's see, a couple more questions. It says, how does funding for research work?
Yeah, that's a great question. So there are many different mechanisms to collaboration with the national labs. So one of those, and the most simple, is what we call a tech collab. So essentially, the Department of Energy will provide funds to cover the ORNL labor associated with the project with industry. And then the expectation is that the industry partner itself will then cover its own people, so no funding changes hands. Those are very, very simple projects to get started for overcoming some of these barriers for industry. But there's also opportunities to leverage DOE funding directly in the form of funding opportunities. We write proposals all the time to the Department of Energy, and we'd be more than happy to speak with you about how we can leverage, especially for larger projects or harder R&D questions. We can tend to use those mechanisms as well to provide funding from DOE to the industry sponsor. But the easiest and most commonly leveraged mechanism, the company comes to us, they leverage the Tech Collab program. There's about $240,000 of R&D by the scientists at the national lab, and that is matched by R&D from the industry partner. We kind of work together on, developing out a new process or a new material, for example.
Awesome. Let's see. And I just got word, actually, our workshop is going to be July 29th and 30th. So, like I said, be on the lookout for some emails. Since everyone that's a part of the webinars will be on our list for future offerings, workshops, webinars, things like that. Another question came in: does Oak Ridge have access to supplies of automotive scrap? I have a customer interested in automotive materials, and then in parentheses it says plastic automotive scrap.
Excellent. Yes, so we do. We have many samples here on site. Be more than happy to close the loop as well between you and people who would be generating that scrap. And also we have really strong relationships with the end-of-life supply chain for vehicles. So we have contacts at the body shops, at the dismantlers and scrap yards, and the shredders as well. So be more than happy to close those loops for whoever would like it. And that's my role. My role is to help enable the industry. So please feel free to reach out, check my ORNL page, reach out to me on LinkedIn, email me, whatever. I'll be more than happy to expedite that process for you. I know it can be challenging.
Got one more question. Well, actually, two more questions. But what I'll do is I'll make sure that this QR code is in our follow-up email for this, so that everybody that was a part of it has Matthew Korey's contact information. So one says, for Vaughn and the Material Solutions Program, is the idea for us to reach out if we have a material we'd like to get rid of, and you'd help us or help get us in touch with a company that may be able to reuse it. So I think basically, if somebody has a waste product that they're looking to rehome, is there like what's the process? Is there a form? Do they just reach out to you, Vaughn? How does that work?
Reach out to me directly via email. Primarily, I would prefer email because that way we can get across and our details to each other pretty quickly, and we'll have a record of what we said. So yeah, again, I can't be expert at everything. Neither can Matt, but I mean, Matt has a specialty. My specialty is trying to know everybody I possibly can to answer your questions and help you out. But we've had a lot of success. About 25 of the last 45 materials exchanges have been a success. So I'm getting a much better return on my time investment. So please reach out to me, and we'll see what we can do.
And same for me. I live in support of the state of Tennessee as well as the national market. So please feel free to reach out to me. I'd be more than happy to help close the gaps between you and who's somebody who may be able to use your material, especially if there's R&D that is needed or technologies that are needed to be developed in order to enable that. So, for example, you have multi-material within your waste, reach out because someone may not be able to directly use that, but they may be able to use it if we can get other things out of it, for example.
Awesome. I think that's all the questions that I see. Feel free to keep sending them if you guys have them. I did open up the last final question over on your right hand side for the Slido. Just wanted to ask one last question before we end today. Based on the information learned from this webinar, do you see any opportunities to implement changes in your facility, specifically to problem waste or a waste product that potentially could be processed back in or processed into a beneficial material for someone else? So if you got the time, feel free to click one of those. Just helps us understand who's out there trying to do these types of things. Let's see, and then like was mentioned multiple times, we will be sending a follow-up email that has the recording to this webinar, the link to our pollution prevention page that has past webinars and resources, and then also the contact information for Vaughn and Dr. Matthew Korey. So let me see, got one more. Okay, well, I think that is good to go. That was just a direct message. I really appreciate everybody joining us today. We couldn't have success with our pollution prevention workshops and webinars and program really without those of you that are out there trying to make a difference and change how we do things. So if you have any questions at all, you've got my email. You will be receiving an email from me in the next couple of days with a follow-up. And we hope that you learned something today and go out there and be great. We appreciate y'all.
Thank you.